In this question, we are asked to find the measure of each numbered angle. Looking at the diagram, we see that the numbered angles are 2, 1, and 3. Let's dive right into it. Looking at triangle KLM, this triangle right here, we see that we are given the measure of 2 of the interior angles. We are able to find the measure of the third angle using the triangle angle sum theorem, which simply states that if I add the measures of the triangle, the sum will equal 180. So let's write out the relationship. The measure of angle 2 plus 57 plus 71 equals 180. Combining the like terms here, 57 plus 71 is 128. So the measure of angle 2 plus 128 equals 180. We subtract 128 from both sides, and we're left with the measure of angle 2 equals 52. So far, so good. Now let's find angles 1 and 3. Looking at triangle JKL, it's clear that we only have the measure of one of the interior angles, and therefore using the triangle angle sum theorem at this point doesn't work. What we do recognize is that angles 1 and this 57-degree angle, these two angles form a linear pair, and therefore by the supplement theorem, they are supplementary. So the measure of angle 1 plus 57 equals 180. Subtracting 57 from both sides, we are left with the measure of angle 1 equals 123. Now that we have the measure of angle 1, that gives us the measure of 2 of the angles in triangle JKL, so we can use the triangle angle sum theorem to find the measure of angle 3. So let's write it out. The measure of angle 3 plus the measure of angle 1 plus 28 equals 180. Using substitution, we substitute angle 1 with 123. We combine like terms. And then we subtract 151 from both sides. And we're left with the measure of angle 3 equals 29. Let's try a similar question. We are still finding the measure of each numbered angle. In this question, those angles are 2, 1, and 3. Now we want to start in the triangle that has the most information. Looking at the diagram, we see in triangle LMN, one angle here measured 31 degrees, and this symbol indicating a right angle, its measure is 90 degrees. That gives us the measure of 2 angles in that triangle, so we can find the measure of angle 2. Let's write out the relationship. The measure of angle 2 plus 31 plus 90 equals 180. We combine the like terms. 31 plus 90 is 121. So the measure of angle 2 plus 121 equals 180. And then subtracting the 121 from both sides, we are left with the measure of angle 2 equals 59. So far, so good. Looking back at our diagram, we also see that angles 1 and 2 are vertical angles. And by the vertical angles theorem, they are congruent. So if the measure of angle 2 equals 59, the measure of angle 1 will also be 59. And that leads us to this triangle down here, triangle NQP. We have the measure of angle 1. We just found the measure of angle 2. We have the measure of angle 1. We have the measure of angle 2. So we can find the measure of angle 3. So let's write out the relationship. The measure of angle 3 plus the measure of angle 1 plus 22 is 180. Let's do our substitution. Measure of angle 3 plus 59 plus 22 equals 180. Combining these like terms here, we have the measure of angle 3 plus 81 equals 180. And then subtracting 81 from both sides, we are left with the measure of angle 3 equals 99. Thanks for watching, and we'll see you in the next one.